Hey everybody, what's up? Time for review video 1 for Unit 2. It's the first time you're seeing me with my normal haircut. You could have nothing held against you if you thought I looked like a homeless person the first time we met in class. And I went all summer, and I was so busy all summer long that I never got a chance just to run in the barber and say, give me a buzz cut, which is usually what I get. I'll get a buzz cut every couple of months. And I was so busy, and I had my teacher conference at the end of August. Then I have to get my lab up and going in the computer science department. Then I have to get things straightened out for my Python class, and blah, 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 blah. And all through all of this, I never had any time to go and get my hair cut. So I just had that silly baseball cap on to keep it out of my face, and it was the longest it had been in years. And I looked like a crazy person, admittedly so, and I hated it. Finally, a week or two back, had time to run into the barber shop and say, cut all this hair off. So now you're finally seeing the normal. It makes the beard still scraggly and crazy, and kind of like a homeless person's beard. But when you contrast it with the buzz cut, it's like, oh, he means to look like a crazy person, and for whatever reason it works. But if you have super long hair and this beard, then it's like, wow, that is an unkempt, sickly man. But it's not the case. So this is the first time you're seeing the real haircut. In a couple of weeks, we'll be back in class again, so you'll be able to see it up close and personal. Another thing, this morning, long story, I'm not getting into it, I don't want to get crazy, but about a year ago I was playing basketball and I popped my Achilles. And it started a cavalcade of trouble, because I got it fixed, and then the first surgery popped, and then I had a second operation, and that operation was infected. So then they had to go in and do a debridement, and a plastic surgeon had to come in and repair the back of my leg and put the back of my leg back together, and I had to learn how to walk again, and blah, 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 blah. So all of a sudden, a couple days back, I noticed that my leg, where the skin graft is getting a little red. And then later that night, this is Wednesday, I think, I had chills, and I'm like, oh no, I can't deal with this. I'm thinking maybe the infection is coming back. So this morning I went to the emergency room, John F. Kennedy, and it turns out it was sunburn. Thank God, because, I don't need to deal with the nonsense I dealt with a year ago again. But it turns out, basically when you do a skin graft and you have an area that's repaired with plastic surgery, it's almost like it's a burn. It's almost like it's a recovering area of skin. It's akin to a burn more than anything else. And it's more sensitive, obviously. I mean, these things don't occur to me until after. But it's more sensitive to things like sunlight. And me, being an idiot, I was at the Morgan State game Saturday, just roasting under the sun. I had a face full of Noxzema that Saturday night. But I probably just dated myself with that Noxzema comment. But the whole thing is, it never even occurred to me to do anything with my legs or anything like that. And if you look at the skin graft, the part of it that was covered by my sock is fine. And it's just the upper part that was bad. And I don't notice until I'm in the emergency room this morning, and the doctor says, yeah, it looks pretty bad, but is that a blister? And I go, yeah, I think it is a blister. And they said, have you been in the sun recently? And I go, yeah, I got clobbered last Saturday, and blah, blah, blah. And we got to talking. Now, aloe. That was the thing. I have an appointment to go see the surgeon, who's doing double duty as the dermatologist, poor man, because he's been looking at the whole leg thing. But basically it's aloe. Treat it like a sunburn. So I was pretty happy. I thought I was going to end up spending the whole weekend sitting in Kennedy Hospital, and instead they kicked me out in pretty good time. So that was good. All right. Enough for the coffee klatch, you think? You want to do some Python? Goodness gracious. This is terrible. I'm not even going to look. I was going to say, how much of your time have I wasted? All right, Unit 2. Unit 2 is a really good unit because, as you see, and we're going to talk about this moving forward, when I teach computer programming, I extract the computer science, throw it off to the side for the time being, and I teach basically 4 different areas, 4 different pillars, if you'd call them. And the first one you've already did, which is just the basics and basic data types and some if-then and blah, blah, blah. You're doing 2 of them this unit. The next thing I talk about is sequences, how data goes in sequences, and then we talk about loops, how to navigate through our data and find different things and do things with it. So this unit is pretty important. It covers two of the bigger areas. But don't worry about the meta right now. Let's just go down to the nitty-gritty. I've got a file for us, and we're going to sit here and we are going to review it. I have my Python shell already up. and I have my strings program. I call it stringslist.py. Now, don't think you have to type any of this in, because I'm going to take stringlist.py and I'm going to put it in your Sakai resources. After we're done, now if we run this, is this already? Yes, it's already set up the way I want it. So I'm going to run this code over here on the side, and we are going to discuss it as we go. Okay? So, strings. Right here, I just define a variable, my string, as the rain in Spain falls mainly on the plain, which is from Dr. Dolittle. And it gives me a nice long string to play with. Strings are nothing but sequences of characters, one after another, to create words, labels. If you weren't using a variable, we sometimes call them string literals, so that we can use them in our programs. So the easiest thing we can do is just to print it, is to print how long the string is. And that's going to bring us to the first thing we want to talk about when we talk about strings. You see right here it says 43. That's how many characters there are in a string. But if you wanted to access these characters individually, which we can with indexes, you'll see down there, you'll notice that we start counting at 0. And it's one of the things about computer science, and people who have taken other languages before, be it Java or C know this. In computer science, we start counting at 0. 0 is the first placeholder for us. So if we want to do, and we'll do it later, we'll look. But if you can see, just right down here, print my string of 5, T is 0, H is 1, E is 2, that blank is a character, okay? Think of it as air. There's always something there. It's just you can't see it. The space is a character. Okay? So that would be 3. The R would be 4. The A would be 5. So down here, when I say print my string of 5, what does it print? Right over here, you see it prints the A. Okay? So that's the first important thing we're going to talk about. As computer scientists, we start counting at 0. And when it comes to indexing or accessing different parts of the string, we start with 0. So that's 0, and it would run all the way to the n, which is 42. Okay? But if we do a len, it says 43, because that's how many characters there are at the end of the day, 43. Okay? Now, we already came down here, character with the index, and I showed you how we get the A. This right here, 5:15, is something called slicing. We can get a substring, or a little part of the string, and print that out. You'll see how it, right here, it does it. It says ein in spa. Okay? We started at 5, which is the A. We realized that before when we printed just that. And we went all the way down to this A right there. But if you counted things, you'd notice that that A is 14. Okay? It's because, and this is the second important thing that we're going to talk about when we deal with strings, when you have an interval in Python, and this is your first time really seeing an interval, you're going to see it again when we do range and loops, and you're going to see it in some other places in Python. But this is an interval in Python. The second part of the interval is exclusive. It's the first thing that you don't want. So what you're telling Python here is start at 5 and go to 14, because 15 we don't want. And that has some ramifications later on down the line. We're actually going to talk about some of that later in this very video. Okay? So when I say 5 to 15, I'm grabbing 5 to 14, because A is the 14th. All right? Now, out of bounds error. Print my string 42. You can see the last character is an N, and it prints the N right there. Okay? What if I said 43? What if I said print my string of 43? So, knowing that strings start at 0, and that's 42, I'm going to ask for the first thing that isn't there. It's called an out-of-bounds error. We rerun, and you can see we get an error. Okay? Python does not allow you to ask for or print something out of bounds of the string. Now, that may sound like common sense. That may sound like, of course not. But people who are C programmers and people who do other languages know sometimes programming languages just let you do whatever you tell it to do. So it would go into memory and say, wherever the start is, give me 43 sections away. And whatever's there comes out. That happens in C. All right? You won't get an out-of-bounds error in C. If you ask for something, C is going to give it to you. That's not the way things work in Python. In Python, you will get an out-of-bounds error. So if you ask for something outside of the bounds of the string, it's going to come back and say, no, you really don't want to do that. As you can see down here, string index out of range. Okay? So be wary of that. I'm going to set things right by running and do that. Okay, so now we're back to normal. Down here, you can see that we can do index math. All right, so I can get my string of 9, and I could also get my string of 9 by doing different math, and you can see those two I's right there for that. That sometimes comes in handy. I know when I do video game stuff, sometimes I'll have a string of characters, and you want to go to different parts to get different parts of the string and use it. If you know what a sprite sheet is in video games, where you can go grab different pictures from different sections of one really big JPEG. Strings are kind of like that too. I can have a 100-character string, and I know that the first 20 are character attributes that I have for a certain avatar. And I know that the last 20 are all the specs I have for a certain enemy. And I can slice into that string and get this information whenever I want, but I'm only keeping one string. So it's kind of, saves me a little bit of memory down the way. And that's something where I might want to use index math in my string. Okay? Because I'll have an offset. I'll know if the enemy's at the end of that string, the offset will be 80. Because I'll want to start at 80. So then I can have something called villain offset and just say villain offset plus 5. And that'll give me the 5th villain thing. Okay? String methods. Little just in time here. And we're going to get into this in Unit 5, but strings are really just these objects that Python is using, and you can run these little mini programs. You're going to learn about them next unit. Unit 3, we're going to talk about functions, and in Unit 5, we're going to talk about methods. Terms are kind of interchangeable, but not. When we talk about methods, we talk about functions that are used in the context of objects. If what I'm saying is confusing, just forget it. Think of them as little mini programs that we can run on our strings. And here, I run a couple of them. I do one called upper, and you can see the result right down here, where it just puts everything in uppercase and prints it out. Now, that change is not permanent, okay? It just does it with the string, and the string is still the same, because I print it out right underneath it, and as you can see, it's still the same. I use another method called replace, and I replace the Spain with France, and then I print it out. The rain in France falls mainly on the plane, okay? Again, not permanent. I print the old one again, and it says the rain in Spain falls mainly on the plane. In order to make it permanent, which we can do the replace. Here, I replace Spain with Germany, and then I just assign it to the variable name. And I call it new string. And then I print new string, and then new string is now a variable that has the string I want. Because strings have a certain characteristic where once we create them, we can't really change them on the fly. If I tried to change a certain letter in a string, it wouldn't work. And that characteristic is called, or that attribute, is called immutability. It's immutable. You can't change it. You can't mutate it. You can't make changes to a string. And it comes into play in some of the stuff we're going to do in a second with lists, okay? Now, the last thing I'm going to do here is I'm going to run a method called count. Now, all count does is it counts the number of times the character n appears in the string. And as we can see, if we run it, it appears 6 times, okay? So take these methods, take these different things that we do here, play around with them. Change them around, do some things that make you curious. Again, this is 2017. Back when I was a kid in college, I had to run out to the bookstore and buy a bazillion books. You don't have to do that. The documentation for all of this is online. So you can go to the Python documentation and learn about all the different string methods there are and all the different things you can do with strings and start tinkering and playing around. Because that's how we learn. Computer science, that's how we learn things, is we grab them and we tinker and we play around. All right? All right, so that's good for the strings. I'm going to say 1, 2, 3, grab our little way of zotzing things out, and I'm going to come up here and grab the list code I want to do. And I don't want that, so I don't need that. I just want to play around with lists. All right, I'm going to rerun this now that I have zotzed all the code out, and now I have the list stuff. Let me get this in a spot where it is readable and we can talk about it. All right, hopefully that works. All right, we just played around with strings. where we made words and we had different characters in different places that we could access with index numbers, and we could slice and grab a subset of it and do a whole bunch of different things. Now I'm going to create something called a list. And I'm going to take the variable, it's called my list, and I'm going to make it equal to, in brackets, the characters, capital L, A, R, S, my goofy name. Okay? So I print it, and what does it print? It prints in brackets, L-A-R-S. So I have a list with 4 items. They are single characters, L, A, R, and S. All right? Kind of easy. Now, similar to a string, I want to print the second item in the list. Like strings, I start counting at 0. So L is 0, A is 1, R is 2. This, my list of 2, should print the R, and it does. All right? That is where strings and lists say goodbye. That is where it's all the same, because lists are much more dynamic and much easier to use. And as a data scientist and somebody who uses Python, lists are going to be your best friend. I say it a bazillion times. I think I said it in the announcement I just did, because today was the day we opened Unit 2. They're like bookshelves. Lists are like bookshelves. They're laying there, empty bookshelves. Wouldn't it be great if the world were like Minecraft and you could just throw a bookshelf anywhere and start collecting stuff and organizing things and boom? That's what it's like in Python. It's like having empty bookshelves laying around. It's fantastic. And you'll see when next part of this unit, we're going to learn about iteration and loops. And as you iterate through large amounts of data and you find what you're looking for because you're matching for criteria, when you find something, you just throw it in a list. List, 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 list. Then when you're done, you'll have a list of all the things you were looking for. Lists are absolutely wonderful. I'm not going to get into it more than that. We are going to start looking at the difference, though. And these are the two differences. One, you can see here, my list of 2 equals 7. So I'm going to take that R and I'm going to make it a 7. Then I print it out. What happens? The change takes. Because unlike strings, lists are mutable. You can change a list on a fly. Just with that assignment command, you can take something and change it. Okay? That makes them different than strings. With strings, you can just use characters, and the string can't be changed once it's created. All right? Now we're going to get to the second part of what I was just saying there. My list 2 is 2, 2.33, the string lars, 34, and another list. And then I print it out, and look what I get. All right? What does that tell us? Lists aren't just about characters and making words. Lists are about everything. You can mix and match data types and collect basically any kind of thing you can point to with a variable. That's why lists are so powerful. It doesn't matter what the data type is. Integers together with floats, strings, other lists. You will see, importantly, later when we learn about object orientation and creating objects, sometimes you're going to want to have a way to collect those. You can use lists for that. Lists are very powerful because there's 2 ways that they are different from strings. 1, they're mutable, and 2, you can use different kinds of data types with them. So here, I throw a list in a list. You can see the first list we had is actually now an item in my second list. Now later on, you're going to figure out that's how we do tables and with columns and rows. They used to be called multi-dimensional arrays in the dinosaur days when I went to school. But now it's just a list within a list. That's all. Rows and columns. All right. One last thing we're going to do is, like I did with the methods that we did for the string, lists also come with a ton of methods. You should go to the documentation and look. One that's going to be very important and that we're going to use all throughout this course is append. I take my list 2 and I append the string one more item to it, and as you can see, it appears right there as I print it a second time. Okay? Strings, lists, they represent sequences. They represent collections of data that we can now index into and look at one by one by using indexing. The difference really is that strings are a simpler data type that we're just using alphanumeric characters to create words, and we can still index into them, but we're limited because they're not mutable. You can't change things on the fly. And you can just use alphanumerics. You can't really use other data types. Enter lists, which I always say are strings on steroids. Now all of a sudden we've got something that's more of a collection, more of a way to group things together. And in this, I can mix and match data types. I could have integers and strings and floating points and other lists and other data types and do all kinds of things with it. And it's mutable. I can change things on the fly. If I have that third item and I don't want it to be a 7, I want to change it to a 4, I can do that. I have, as the programmer, I have great flexibility with lists, and I can change things up and down. Okay? Now, remember, I'll say it again. Don't bother typing this code in. I'm going to take this code, I'm going to put it online for you. All right? We have got one more thing that we want to do. And it's fun, and I usually do it every time we do this video. Let me make sure. Yes. All right, I don't need that. Let's see. I should get nothing, right? Yes, I get nothing. All right, let's make this neater. All right. Yeah, we could do it down here at the bottom. I'm going to stick down here at the bottom. I have a string. It's called string 4, and it equals hello world. From long, solid years of computer programming experience, I happen to know that hello world has 11 characters. The word hello, a blank space, and the word world. All right? So, let's go look at some of the insanity with indexing in Python. I'm going to say string 4, and let's start with the very basics. I'm just going to print 0. All right? And it gives me the H. Thank goodness. I start counting at 0, so if I index into this string, the 0 should be an H, and it is. All right, we are in pretty good shape as far as that's concerned. Now, what if I want to do the last character, the D? That should be 11, right? So string of 11, save, run. Oh, that doesn't work. What is that? It's because we start counting at 0, 0, 1, 2, 3, all the way down to 10. So 10 works and gives me the D. When I had the 11, I had an out of range error because it was too far. But here's the confusing part. If I slice, but I give you the entire string, 11 is fine. Okay? Because 11 is the first thing I don't want. Now, if I ask for it by itself, as we saw, it blows up. It's out of range. But if I use this as the end of a range, I'm in pretty good shape. All right, ready for some weirdness? 12. What is that? That's 2 past the end of it. That's 0 all the way up to 10. 11's the first thing I don't want. 12? What's... So that shouldn't work, right? Something weird about that? Uh-oh. It works. Works pretty good. What happens if this is... That works too. Super large. I remember in one video, I went up to 8,000. Still works. Okay? I think I know why. It gets kind of technical. But in Python, you can have the end of your range be arbitrarily large, and it's still going to print your string for you. Okay? I just think it has to do with, instead of throwing an error, Python wants to say if they make that, if the end of the range is arbitrarily large, then you can use the command for a whole bunch of different strings, and you don't have to know exactly where the end is, and you don't have to do a len on everything. Back in the old days, we'd do a len on it, and len -1 would then be what you print it out to, and blah, blah, blah. Well, I think this is just a little Pythonic kind of shortcut to get you to printing the entire string, all right? This is the way I came to it. A student wanted to do things with reverse indexing. And if you remember your slides, oh, brackets, goodness, could you imagine? If you remember your slides, you'll remember that reverse indexing starts at the back of the string and goes backwards. So -1 is the D, -2 would be the L, and so on and so forth. So this student wanted to play around with substrings with reverse indexing, so that the student, I believe, wanted to print out OR ORL, I think it was. So they said, give me -4 to -1. -1 is the first thing I don't want, so I should get ORL. And they did that, and look at that, ORL, it worked. So you got the O, because this is -4, -3, -2, and -1 is the first thing I don't want, blah, blah, blah. It didn't work, okay? This is the problem. What if I did -1 to -4? What happens? Nothing. 0. The string returns 0. Because Python doesn't like it if you're not going left to right. If you say start here and move backwards, it doesn't like it. So you say to yourself, okay, well, go backwards then. I'll let you go backwards. For my third parameter, as I'm doing an index, I'm going to say go backwards. Okay? And that's the way we go backwards when we do indexing. All right? The third thing, it defaults at 1, which is move forward. But if we put a -1 in there, we can tell it to go backwards. And then we get DLR. So we get D is the first thing, right? -1. LR, -4 is the first thing we don't want. So that kind of works. So we figured that one out. But here's one thing that's pretty much never going to get figured out. The student then said to me, I want to print hello world, the entirety of the string, but I want to use reverse indexing. So I said, okay, A, why would anybody want to do that? But you don't ask that in computer programming. If somebody wants to do something, you try to do it. So let's say string of -11 is the H. All right, so we're in good shape. So now I want to do an index. Do I want to go to -1? Well, remember, it's an index. So -1 is the first thing we don't want. So if I do this, I get hello world. Okay? I don't have the D. I can't grab the D. So the student, logically, thought, okay, what's the first thing I don't want? Figuring you would add 1 to the end of the range and give it a 0. There's a problem, though. That doesn't work. Because in 0, in the indexing world, means that H. So it's almost like you told it to start at the H and go all the way to the H at the beginning. It doesn't go. It doesn't work that way. So as far as reverse indexing is concerned, you're stuck with that. So what I told the student to do is use the plus sign. The plus sign, in the context of strings, is called concatenation, which is a highfalutin computer science term for slamming two things together. Google it. All right? If you use a plus sign with strings, you're going to slam those two strings together and create one string. All right? So what I want to do here, is that. Okay? Now, when I do -1 alone, it's fine. It'll give me the D. I'm not doing it as part of an interval. So here I say give me -11, hello world, all the way up to the first thing I don't want, which is D. But knowing with reverse indexing it's kind of a problem, I just add the D back in at the end. So now when I run it, dun, 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 what am I doing wrong? Dun, 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 dun. How about putting string 4 in there? Because that's the string I want. So now it says hello world. Okay? So that's the way we got around that issue. The reason I do this now and the reason I play around with this stuff is that I want to show you that this is how we learn, this is how we do things. Tinker with this stuff. Play around with things. Reverse index. See what you can do to what you can do and what you can't do and how far you can go and where you can go. And play around with all these things. You'll find that every once and again you'll hit some boundaries and Python has some weird idiosyncrasies. But at the end of the day, it's fun to figure all of this stuff out. That's pretty much it. What we're going to have today, my friends, is a fairly decent finale. All right, let's save that and run it. Look at that. We got some okay stuff there. All right. Again, for the last time, I'm taking this code and I'm putting it online for you, so you have no worries. You can just go there and grab the code there. As far as announcements are concerned, we are in pretty decent shape. I like what I saw from Unit 1 because everybody was able to go do a forum post. Everybody was able to submit assignments. Everybody was able to take the quiz and get it submitted on time. That tells me you're cool with Sakai. and you're cool with the different mechanisms we use in this particular course. So that's part of one of the big things for Unit 1 is getting you familiar with the way I do units and the way we use Sakai to do all of these things. Mission accomplished. So now we can concentrate on the cool stuff, Python, and worry about learning Python. Next week, see, I'm not going to go long into announcements because 2 days from now I'm going to do the second review video, and I can do all the announcements then. It's not a problem. We're not going to meet again until October, so that's not for a couple of weeks. We'll get there when we get there. Actually, when is it? The 3rd? This unit ends on the 5th, which is a Thursday, so I'm assuming we're meeting on the 3rd. So we'll talk about different things. I am going to get you in probably the middle of next week all of the information you need for your midterm, because you're going to want to get going on that. I believe that's due in the first week of November, so I want you to have at least a month to work on that. You'll know why when we get all the information. Other than that, keep doing what you're doing. Right now, read the slides, read the Zell, tinker, play, watch these review videos. In the middle of next week, Tuesday, Wednesday, I'll get you the assignments. All right? You'll have an entire week to work on the assignments with all of your resources for this unit. And as you'll see, I mean, you read the slides. I'm going to do this video. I'm going to do a second review video where we're going to review loops and different kinds of loops and things like that. And then I'm going to do a third video for this unit. It's not really part and parcel of the resources, though. So if that doesn't happen until the next weekend, that's not a big deal. I don't consider... It's going to be basically a video where I do the Project Euler number 6, like I promised in the slides. We're going to go... I'm going to tell you what Project Euler is all about. I'm going to tell you why I use it. And we're going to go there and we're going to basically code up number 6. And I'm going to show you how I do that using loops. Okay? But that's not really necessarily what I call a canon or the canonical resource for Unit 2. That's going to be like your little added extra for the week. So I want to make sure by Thursday of next week you have your slides, which you have your assignments, you have your Zell readings, and you have both of your review videos. So you have all of your resources, you're set, you're good, and then you can get to work on the assignments, and then you can use those resources to prepare for the quiz, which is going to be October 5th, all right? Take it easy, take it slow. Make sure it's fun. Should be fun. It's interesting stuff. And everyone's doing great, so you have no worries, all right? All right. Then gobble up this video. I will do the second one in the next couple of days. I don't know. Now that I'm not going to be spending the weekend in the hospital, I'm probably going to jump down to my sister's house. One of my nephews is playing football for Lenape now, so I may go down and watch him play football. Maybe even end up watching the Giants and the Eagles down there. We shall see. All right? But I'm going to definitely get that second video to you very soon, and we'll be all right. So you got no worries. All right? Then I'm going to get out of here. You be good, and I will be in touch in a few days. Talk to you later. Bye.